So the first derivative test. So let's look at this theorem first. Let C be a critical number of a function f that is continuous on an open interval I containing C if f is differentiable on the interval except possibly at C, then fc can be classified as follows. Number 1, if f prime x changes from negative to positive at C, then f has a relative minimum. Okay, so negative to positive, then the relative minimum. And now f prime c changes from positive to negative, then this becomes the relative maximum. And f prime x is positive on both sides or negative on both sides, then fc is neither the relative minimum nor maximum, basically. Okay, then this case, I'm gonna say maybe inflection point, which we can apply the second derivative test. Okay, then it is really obvious. So come on, look at this picture here. So now we all know that f prime x means, this means tangent line slope. Okay, just centering on some value c here. If one side decreasing, the other side increasing, that this must be minimum. And now left side increasing and right side decreasing, then that must be maximum. That's the whole point here. So after we determined basically quicker value, and then we find out some testing value, and look at that, right side negative, left side negative, right side positive, then minimum. And then left side positive and right side negative, then maximum. That's it. If you feel a little bit confused, then draw the graph. Okay, graph or something like that. Then that's it basically. Okay, then look at one example. So I'm gonna make it a little bigger. So find the relative extrema of the function fx equal to 1 over 2x minus sin x in the interval 0 to 2 pi. Okay, so let's try to do this problem. So first of all, we need to find out f prime x function so that we can find out the critical value, right? Okay, so this become 1 over 2 because derivative x become 1, so 1 over 2 times 1 becomes 1 over 2, and minus cosine x. That's the derivative here. And because we want to find out the critical value, so just make derivative function equal to 0. Then from here, we can find out cosine x equal to 1 over 2. Okay? Then which radian value in the interval 0 to 2 pi, the cosine x become 1 over 2. So if you think theta equal to pi over 3 and then 5 pi over 3, then you have a correct answer. Okay, and simply I just drew the unit circle here. Then cosine half means right here, so this radian and then this another radian here. So we can say pi over 3 and then 5 pi over 3. Okay, so then we can make interval here. So pi over 3 and then 5 pi over 3. So let's find out any testing value. So we know that we have 0 here and 2 pi here. That's the open interval, so they are not including this interval value. Okay, so what about we just do pi over 6? and maybe, shall we do maybe pi? Why not? And after that, we can do 11 pi over 6. They're all testing value here. Okay, so if you plug in into where? Basically here. Don't forget that. Okay, because we are testing how the tangent line slope kind of fluctuate. So we are inputting those testing value into the f prime function. Okay, so let's plug pi over 6 first. So this case, we actually don't understand the exact value of pi over 6. So you may using a calculator or just start plugging anyway. So f primes pi over 6, which is 1 over 2 minus cosine pi over 6, right? Okay, so we know that cosine pi over 6 become root 3 over 2, so 1 over 2 minus root 3 over 2. You know that this is actually bigger, so become negative here. So do you understand what I did? I didn't calculate that. I know root 3 over 2 is bigger than 1 over 2. Why? Because 1 over 2 is right here, but root 3 over 2 right here. So it is further than 0. So I know root 3 over 2. So smaller minus bigger become negative. That's why I just put negative here. Okay, now pi. So f prime pi, which is 1 over 2 minus cosine pi, which means 1 over 2 minus negative 1, so plus 1. So I don't even calculate it. I'm going to say positive here, so plus. Okay, now 11 pi over 6. So f primes 11 pi over 6, then 1 over 2 minus cosine 11 pi over 6. So this becomes 1 over 2 minus root 3 over 2, which means still negative here. So I put negative. Okay, so that's the hint. So, if you look at the theorem, then you got really confused. So I recommend you may just do the kind of slope, basically. Negative, so negative slope, positive, and negative here. So when you look at this point must be minimum. This point must be maximum, basically. Okay, therefore we know that the relative minimum at x equal to, what's that, pi over 3, and then we have relative maximum at x equal to 5 pi over 3 here. Then how to find maybe minimum point and maximum point? Can you think about what should we do? Yes, exactly. We input this corresponding x value into the original function, not derivative function anymore, because we want to find out their coordinates. So you're going back to the original function. So I'm gonna do, so f pi over 3, it means 1 over 2 times pi over 3 minus sine pi over 3. Therefore it becomes pi over 6 minus, and then sine pi over 3 is root 3 over 2. Okay, so let me calculate that. So this is about negative 0.342, and then f 5 pi over 3, it means 1 over 2 times 5 pi over 3 minus sine 5 pi over 3. Therefore, this becomes 5 pi over 6 minus, so negative root 3 over 2. It means 5 pi over 6 plus root 3 over 2. If you calculate that, you'll get 3.484. Okay, therefore, now we can make, so the relative minimum point will be pi over 3 comma negative 0.342, and then the relative maximum point will be 5 pi over 3 comma 3.484. Okay, so that's all today, and then we will cover next topic from the next video. Thank you.